Hello friends, welcome to my fourth lecture on logarithm, and this will be the last lecture for logarithm chapter. In the next lecture I will be discussing about the applications and uses of log tables. In this lecture I will be solving some questions based on the properties of logarithms. Solving questions is very important in mathematics. Please do solve as much as possible. The first question is, if x is equal to 1 plus log bc to the base a, y is equal to 1 plus log ac to the base b, and z is equal to 1 plus log ab to the base c. You have to prove that xyz is equal to xy plus yz plus zx. I will again suggest that you pause the video, solve the question, prove this identity, and then you can play the video and see the next slide for the solution. I will be explaining you the solution now. See, what you have been given is x is equal to 1 plus log bc to the base a, and here you see this 1 is the main problem. The first thing comes to your mind is, let's start solving the subtracting the equations. We go to the question and we see that if this one is the problem, so first thing strikes is that we subtract x minus y, this one will be cancelled, and then we will apply some property, but then you will be landing in a problem. So what you have to observe is, you have to combine all these. You are multiplying x, y, z. So this is only possible if you get log x plus log y plus log z. So what we do, we write this as log a to the base a. 1 is log a to the base a. Now if you combine, you get log abc to the base a. Another hint is that what we are given to prove is, 1 minute, is xyz is equal to xy plus yz plus zx. So if you take this to the RHS and divide, you will get 1 by x plus 1 by y plus 1 by z. This is a very big hint. If you remember this expression is equivalent to 1 by x plus 1 by y plus 1 by z is equal to 1, and this is a very big hint. You have to find 1 by x, 1 by y and 1 by z and prove that sum of these is equal to 1. Let's see. So we get x is equal to log abc to the base a. Similarly, we will be writing y is equal to log abc to the base b, z is equal to log abc to the base c. But unless the base is same, multiplication, addition, division properties cannot be applied. So what we do, we bring this number to the base, and for that, interchanging these numbers, we need to bring it to the denominator. So 1 by x is equal to 1 upon log abc to the base a, or we can write it as log a to the base abc. By performing similar operations, 1 by y is equal to log b to the base abc, 1 by z is equal to log c to the base abc. Now nothing more is required to be done. You just add 1 by x, 1 by y, 1 by z. It becomes log a to the base abc, log b to the base abc, log c to the base abc. Addition means we can multiply these numbers. So log abc to the base abc, this is nothing but 1. Log a to the base a is 1. We get, and taking LCM on the LHS, we get xy plus yz plus zx upon xyz. This xyz goes to the RHS, we get xy plus yz plus zx is equal to xyz, which we were required to prove. Let's do one more question. Again, I don't need to remind every time that you pause the video. Try the question first and then proceed to the solution. Here you have been given that if ABC are 3 consecutive positive numbers, then find the log 1 plus AC to the base root b. Try this question and let's see the solution. See, these type of questions are mostly asked in objective questions. So I will be explaining you one objective approach and one subjective approach. Subjective approach is straightforward. You go, since ABC are consecutive numbers, you assume A is 1 less than B and C is 1 greater than B. A is equal to B minus 1, C is equal to B plus 1, and you should always assume consecutive numbers like this only. Don't assume that a is equal to a, b is equal to a plus 1, c is equal to a plus 2. It is not going to make a big difference in this question, but still it's generally a good practice for solving questions, because if addition is involved then this one will get cancelled. But let's focus on the question first. 1 plus ac is equal to 1 plus b minus 1 into b plus 1. A plus b into a minus b means b square minus 1 minus 1 plus 1 gets cancelled. You get 1 plus ac is equal to nothing but b square. Therefore, log of 1 plus ac to the base b is log of b square to the base root b. You bring this 2 outside and multiply. Bring this 1 by 2 power outside and divide. You get 2 by 1 by 2 multiplied by log b to the base b, which is equal to nothing but this 2 comes up, gets multiplied with 2, 4, and this is 1. Objective approach is, for these type of questions you can safely assume that a is equal to 1, b is equal to 2, c is equal to 3. Don't go and assume a is equal to 9999, b is equal to 10,000, c is equal to 10,001 and all that. Assume simple numbers because you want to save our time. Objective questions, answer matters, save your time. Assume simple numbers and then 1 plus 3 into 1 to the base root 2, you will get log 4 to the base root 2, same powers go outside, gets multiplied, and you will get the same result. Let's do one more question. Prove that 1 upon log xyz to the base xy plus 1 upon log xyz to the base zx plus 1 upon log xyz to the base yz is equal to 2. First of all, I will be explaining you the question. You pause the video, try your level best, get the solution, and then proceed to the next slide. I will be telling you some properties, how to proceed about the questions. First, you have to observe the question very carefully, because you won't get the nail driven inside the wall by hitting on the wall. You have to hit the nail on the head. So, you have to first decide where to hit. Hitting on the right spot is very important in mathematics. You observe that everything is in denominator and it's reducing to a numerical value. So it means this entire question will be reducing to log a to the base a kind of thing. The bases are different in every case, but the number of which we have taken the log is same. So what we do, we bring these numbers to the base. So we can write it as LHS is log xy to the base xyz plus log zx to the base xyz plus log yz to the base xyz. When we bring the numbers to the numerator, the number and the base gets interchanged. Now the bases are same, we can apply the multiplication property. Log xyz, everything is twice, gets multiplied. Xyz whole square is xyz to the base xyz, 2 gets outside, log xyz to the base xyz is 2, hence proof. One more question, log m plus n is equal to log m plus log n. You have to prove that m is equal to n upon n minus 1. Remember my friends, whatever is given over here, this is not a property of logarithm. Remember, if you apply that log m plus n is equal to log mn into m plus log n, this is not the property which we have studied. The question clearly specifies if this holds, then you have to prove this one. This is not the property. So what we do is apply the property over here. Sum of logarithms is log of product. Okay, let's look at the solution now. Log m plus n is equal to log m plus log n. Here we can apply the property. We can write it as log m into n. Remember my friends, if the base is not mentioned in the question and the question has been given to you in an examination, you can very well assume, very safely assume that all the conditions of logarithm are satisfied. Don't assume that the base could be 1 and then its question is not solvable. You assume that the base is not equal to 1 and then proceed forward. We can say that if logarithm of these two numbers is equal, then we can say that m plus n is equal to mn. Bases are same. We take n on this side and bring this m over here, take m common, bring it to LHS, and you will get that m is equal to n upon n minus 1. This is just solving for the value of m. We'll get the answer. Let's do one more question. If a and b are two positive numbers such that following relations hold true, you are being given two relations. One is log a to the base 27 plus log b to the base 9 is equal to 7 by 2, and log b to the base 27 plus log a to the base 9 is equal to 2 by 3. You have to find the value of ab. Remember, my friends, that this log a to the base 27 plus log b to the base 9 and this expression, we don't need to find ab, we need to find a into b. We don't need to find a separately and b separately, we need to find product ab. So there could be a different approach for solving for a and b because there are only two variables, and for two variables two equations are sufficient to solve. You can solve these two equations simultaneously and get the values of a and b. That is also one of the approaches, but that will be a lengthy approach. What we do, we add both the given relations. When we add both the given relations, then you see, if you add both these two relations, you will get that a to the base 27 and b to the base 27 both are present over here. Log b to the base 9 and a to the base 9 both are present over here. So you can combine these two and these two. You will get log a into b to the base 27 plus log a into b to the base 9. Now this 27 could be written as 3 cube, this power 3 goes outside, 9 could be written as 3 square, power 2 goes outside and gets divided. We are getting 1 by 3 log ab to the base 3, 1 by 3 2 log ab to the base 3 is equal to 25 by 6. Now this log ab to the base 3 is common to both the terms. You take common, add 1 by 3 1 by 2, you will get 5 by 6. Cancelling everything, we get log ab to the base 3 is equal to 5, or ab is equal to 3 raised to power 5 or 243. So since we were required to only find ab, we use this approach. If we need to find a and b separately, then you convert log a to the base 3, b to the base 3, b to the base 3, a to the base 3, and then solve considering a to the base 3 and b to the base 3 as new variables x and y. You can solve for x and y, but that will be a very lengthy approach. So my friends, thank you all for watching. This completes the complete logarithm chapter. The next lecture will be on use of log tables, how to use it. There are certain properties of logarithm and log tables applicable to chemistry and physics also. Please do subscribe to my channel YLC, that is your learning curve. Don't forget to press the bell icon. Please do suggest in suggestions box. And at the end of every lecture, I say, remember, practice makes man perfect. There is no substitute for hard work. Thank you for watching.